discussion.
Cool, awesome. So we're gonna start on the losses and metrics based on model internals as we finished the previous section. Let me share my screen. 1 second. Okay. Okay, so everyone can see my screen, right? Okay, so we're gonna go through the codes. Again, this chapter is more focused on code rather than text, so I won't be, reading too much text. But if you have any questions from the text, feel free to, kind of point it out as we go along. Okay, so the reconstructing regressor, basically we're reconstructing our own kind of regressor. Now, anyone had trouble loading this? Because I couldn't get through this era.
Yep.
I
Me
had the
too.
same issue.
Got it. Okay. Anyone solved it? Maybe? Debugged it? No, no one? Okay. All right. So, again, we're just building classes, kind of custom classes that inherit from sort of a parent class. And I want to also talk a little bit about this quarks a little bit. Anyone, has anyone used this quarks in work or in whatever they do? Not in terms of general like writing a function, but with inheritance, using inheritance and quarks at the same time. What could be a great use case to use quarks? Because I think in the cases that he brought up, you can delete the quarks with no problem, and they still run like these ones. So I was just curious to see, has anyone, needed to write functions or sorry classes with the inheritance then and also the quarks.
Yeah, Corex helps with the how do I say it, dictionary type of key value pairs. So
Mm-hmm.
we can use it to provide some sort of uh, property file that is needed. For example, in a, language binding case, in which suppose you need to dynamically I'm taking an example from my earlier days at the start of my career, uh, in which I used key value args for uh, a way to provide localization with respect to different languages. So once more how do I say it, languages or the locales were added, I use that as a mechanism to load more key value args with respect to different languages like French, uh, Italian, and such.
Right.
So,
Yeah.
yeah.
And that's right. That's the general use case of quarks. But I'm talking about how do people use it when it comes to inheritance? Because from what I've known, and I've gone through some tutorials previously when I was learning about inheritance, um, in super. So these dictionary arguments can pass through the parent classes, and not just the parent class. It can go through the method resolution order through all these ones, and these dictionary items can only be used once. So if this one gets to use one of the dictionary arguments, then this one can't use it anymore because it's gone. So I was wondering, if anyone has that kind of experience of
If
designing
you look
like
at
classes.
FastAI, for example, you'll have like a base optimizer that's defined or a base loss function that's defined.
Mm.
Then you'll have a bunch of parameters that probably are set by default. Let's say batch size and certain things like learning rate is something that you would pass in. I can't think of anything else at the top of my head right now, but let's say batch size is equal to 32 is like the default parameter that's already set. Now, if you go and build Adam inheriting from that class, you can change a bunch of things there. But then since you're inheriting from the base optimizer already has, let's say, batch size and stuff like that. So that's one place I've seen like where FastAI uses like the keyword house. So then you
Got
kind
it.
of pass it through like that. So I
Got
think
it.
we use it, same thing with losses and a bunch of other things that they use.
Got it. Cool. Thank you. And I just want to also raise attention to the MRO. When we try to kind of, customize our own classes using subclassing API, and you always want to kind of check a little bit on the MRO to see, the order. And what MRO is, it gives you an order of execution on all the classes that this class is when you initialize the parent class, it will execute through all these parent classes, meaning this one is inheriting from this one, and this one is inheriting from this one, so on and so forth, all the way to this last one. And it then becomes an object. So so you want to make sure, you want to check, because sometimes there could be, multiple inheritances. Then, what's the order of execution? So you want to check this. Okay. This is this, I guess, comes back to it, the object-oriented programming. Normally, I guess, when it comes to just data science, we might not deal as much as with some of this stuff. But when it comes to writing, your own customized functions, your own library, or the entire program, then you have to kind of deal with these. So, okay. So, any questions? Any comments up to this point? Okay, so self.hidden, we're just defining a bunch of hidden layers using char.layers.dense, and in this case, we're using 30 units, Selu activation function, Lacan normalization, and we need 5 layers, the same layers. Then we have an output layer as a dense layer, and using output dimension. And again, this builds, you can't really change in this call. You can't really change the name. You're just overriding what was already existing in the char.models.model. And when we first well, I guess, when you see super, it just means this. Okay, so this is equivalent to model dot build batch input shape. Okay, so this super just means this. So every time you want to call the parent class to do something, you just use super. Okay, that's how super is used. And okay, and when you want to pass in, let's say specific arguments, then you just write argument 1, argument 2, and of course you can just pass in quarks. Okay, and what this does is you're basically just calling the parent class to build your batch input shape with builds, and with batch input shape, you're sort of rebuilding this. And okay, and I have no idea why this doesn't run through. And it seems like an error from TensorFlow end rather than the model end. And also, I think he did put some comments here. Maybe there are issues that haven't been resolved from TensorFlow's end. I don't know. Yeah, so this is, again, I believe this is the residual connection, and adding the loss and have the output right here. Okay. Anyone else has any questions before we move forward? Maybe from the text as anything?
There is no residual, right, in this one? It's just running through for layer in self dot hidden Z layer of Z.
There is no skip connection, but
You're not doing Z plus input, right?
let me just double check. Isn't that's skip connection, right?
They're the same thing, right?
Is
there a difference between skip and residuals?
I'm not sure.
I think just two different names. Skip just directly show how it skips over a certain part and then it runs, and a residual is just talking that you're adding the remainder back in.
Okay.
That's what my understanding was.
Okay, because I saw him using different contains loops and skip connections. Residual block composed of 2 dense layers in addition operations. So maybe you're right. A residual block is 2 dense layers plus addition operations. So it consists of skip connection, which is this part.
Right.
Okay. Right. So this is not a residual block. It's not using residual block. Okay. Great. Thank you. Okay. So let's go through the computing gradients using Autodiff. And I think it was John who raised a question about, I think he said, basically PyTorch, you can, kind of attach the gradient, then it will to the variables, and it can keep monitoring, whether a variable, it can keep monitoring and tracking the gradients of that variable. And he was asking whether TensorFlow has something similar. And I think I pointed him to this gradient tape during that session, and it is the case here. If you call this with tf.gradient tape as tape, then it will track every operation of the variables passed in, which are W2, W1 and W2. And so then, you can call this tape.gradient and to get your gradients outputted. And this is the context with context statements. So pretty cool. But I guess, I think I would prefer PyTorch method a little better, because you can literally, you don't have to write this. I guess you can literally just pass in as some sort of argument. I think it was grade equals to true or something like that. Something, yeah, which allows you to kind of pass in a parameter to allow the gradients to be tracked.
So Wenchang, what I understood from that was that basically you need to make something a variable if you want all the operations to be tracked on that.
Mm-hmm.
And then you can calculate the gradient with respect to those variables.
Right.
So here the key is that you're making W1 and W2 TF dot variable, right?
Mm-hmm.
And then whatever operation you're doing, that graph is kept. And then gradient tape is just taking the gradient of that with respect to Z is your final output. And you're saying, since you know how to get to Z from W1 and W2,
Mm-hmm.
calculate what the gradients are with respect to W1 and W2.
Yep.
Okay.
Yep. That's right. And I think he mentioned right here, it says, we create TF.gradient tape context that will automatically record every operation that involves the variable. And finally, we ask this tape to compute the gradients of the result Z or Z with regard to both variables. So and you can see from, I think later on when we talk about this, look at this block, right? So the variables are kind of hidden. It's not showing TF.variable here, but it's tracking the TF.variables in these named variables right here with this, with statements context block. Then you can tape.gradient loss model of training variables, right? So okay, and obviously this is pretty easy calculation. He did it by hand. I think he showed it somewhere, and it's 36 for W1, Z with respect to W1, and this is with respect to W2, I believe. And interestingly, this can only be called once. So I don't know why, but anybody know why this was set up this way? Once you call it, it's erased immediately. Okay. Yeah, but you can just set a parameter here, persistent equals to true. Then you can, keep calling it, and if you need to call more than once, then you just set this parameter. Then you delete this to free the resources.
This is a guess, but my guess is that typically contexts have an enter and an exit, and so a single exit might mean that the context is exited, whereas you might need to set another flag to make sure that you store it somewhere, and therefore, like if you open a file and you with something as f, then f.close will be called on the first exit. So if you don't want the file to be closed, then you may need to do something like set a flag.
That could be true. Yeah. Cool. That's a reasonable argument. Okay. And there's tape.watch. Okay. And this basically allows you to calculate gradients for tf.constant. Okay. Not just, we've been calculating gradients for tf.variable. And obviously those are the ones that we set to be our weights, right? We don't use tf.constant for our weights. It's always tf.variable. And if you recall what we said, Python doesn't have constant or variable difference, but JavaScript does, and but TensorFlow also does. There's tf.variable and tf.constant. Okay. And if you want to basically quote unquote watch the gradients of the constant tf.constant, then you use tape.watch. C1, C2, and C1 and C2 are constants. And you also would just use tape.gradient to call that. Okay.
Sorry, I missed something. Is you said C1 and C2 are constants, right?
Mm-hmm. Right here.
Why? Sorry, basic question. Why do we want to do gradients for, gradients of Z with respect to C1, C2?
Mm-hmm.
Oh, okay, I see.
Yeah.
And then they,
yeah. Yeah, he's just demonstrating like you could also, calculate gradients with, if you don't do tape.watch, you wouldn't be able to calculate or get the gradients for constants because it's just set up this way. It's not allowed to change.
I see.
Yeah.
Okay, thanks.
Yeah, the tape only tracks operations involving variables. Yeah. And if you do try to do that, the result will be none unless you do tape.watch. Okay. I think the rest of the stuff is, I think he's just basically demonstrating more. You can also get Hessians. So not just basically first derivative, you could get second derivative.
Okay. I think this is the reason why you need to set persistent as equal to true, because usually when you're doing a calculation and you're trying to do backprop, you're just going to run through it once, right? There's no reason, like in general cases, when we do backprop, you're just going to run through it once. And the reason why it clears everything out is because that is taking up resources. Memory is being occupied by that. Once you do a backprop, you really are going to use it. So that's why it's set up in a default manner where it frees those resources.
Yep.
Now, given an instance where you want to do a second derivative, then you have like a persistent is equal to true situation.
Yep. And we have two context blocks here. One handles the Jacobian, which is the first derivative. Jacobian is just basically stacking the gradients together into a kind of a gradient matrix, if you will. And that's what it is. And once you calculate that, then you get out of that context block, get your second derivative, which is your Hessians. And you calculate in that way. You kind of loop through each Jacobian and get your Hessian. Okay. And Hessian is just basically your Jacobian with respect to your W1, W2. Okay. And again, Jacobians are just first derivative, 3610, so they're not changing. The Hessians are the second derivatives. Okay. I think he also mentions something about my softflux function. And also using custom gradients. He was just saying basically, you know, sometimes when you deal with you know, certain calculations, Autodiff would end up computing infinity divided by infinity. And this is because using Autodiff leads to some numerical difficulties with certain functions due to floating point precision errors. And then you can kind of get around it with 1 plus 1 divided by exponential, and using a decorator. Is everyone familiar with decorators? Do I need to explain what it is? Okay, so decorator is basically just a function that takes in the function to return, and which alters that function's behavior and returns something else. And in this case, we're saying, okay, we're writing our own soft plus function and input that into a function that's called custom gradient and output something else. Okay, rather than directly using this function.
Yep. Just to add, it's a kind of a wrapper that's placed around a function that can bound your inputs to a particular. That can also bound your inputs to a particular tensor, for example, here.
Yeah, yeah. Okay, cool. Thank you, Mayank. Okay. So we're getting to custom trailing loops, and this is a little dense. But this is super interesting and important as well. Okay. So now he's just writing basically L2 regularization, calling char.regularizer.L2 0.05. I think that's the hyperparameter you specify for L2. And then you have a sequential sequential. Again, we've seen these two layers previously, but now we're adding the kernel regularizer, which is the L2 regularization. Now, remind me, in neural networks case, are we just basically regularizing using a similar type of function or mathematical formula for all weights? You know, let's say
Yeah.
if it's a linear regression and L2 is rich, then, you know, obviously we're just basically regularizing all the, I believe it's all the thetas. In this case, it's all the weights.
Yeah.
Is that okay?
All the weights of the layers, basically. So that's why you see two regularizers, one for the first dance and one for the second dance.
Mm-hmm.
And you basically, let's say this is L2, right? So you do sum of weight squares, and that hyperparameter that you pointed out is multiplied into that. So it's 0.05 times W1 to Wn squares.
Mm-hmm. Right. Cool. Okay, and this is just basically randomly getting the batch and using this random numpy.random.rand integer as the index. Okay, then you get your random batch with a batch size of 32. Okay, and this is quite interesting. I always wonder how these status bars are getting printed, and it turns out it's almost like it pretends to be a status bar. It's really just, you know, replacing the previous bar with an, you know, kind of a new update, if you will. Then you use this carrier. If I take it out, and you will see something very interesting. It would just turn out to be this. Okay, and what it does, what this does is it replaces. So it uses the second one to replace the first one, and the third one to replace the second one. So, and with also this end, obviously, right? And it just basically attaches, right? Instead of starting from another line. So with these two things, you're almost kind of faking, you know, faking it or pretending you have a status bar, but it's really just rewriting every line all the way to the beginning. Does that make sense? Does anyone have any questions on this?
How did you remove the carrier?
Just doing this. This /r is the carrier. Yeah.
Yep. Yeah.
Yeah. So if iteration is smaller than total, then it will keep running. Yeah.
So I had a query with respect to this. This is using your main thread to execute to print the progress bar. So can we use some sort of async method here to uh, uh, perform calculations in the background? So your main thread is, yeah.
Async. What do you mean performing async operations on the background?
I mean, since it's printing and updating the status bar again and again at each time interval, whatever the, if we, I'm thinking from a more optimization and CPU cycles perspective, in which, yeah, your main thread is being your main CPU cycle has been utilized to just print this progress bar. I was thinking in a more async way, in which after certain durations you can give some sort of a update, like 10%, 20%, 30%, the progress that has been done. And instead of trying to uh, uh, have your main thread display and update this same statement again and again, you can have some sort of an async call that does that in the background, and then you can print it.
Yeah, that's a great
Shouldn't this be in sync,
comment.
though, man? Like,
Pardon?
Shouldn't this be in sync though with that? Because every time you're printing, you're basically reaching like the end of an epoch, right? Or an end of a step.
Yeah.
I agree, like you're wasting resources on your main thread though, but then you're saying like probably you'd have a lock. That is the approach you're saying? Because I don't see how async otherwise makes sense here.
Not some sort of a lock, but some sort of a callback with respect to we can prevent this just to make it better. Yeah, for example, the size here is 30, and what we're doing is trying to regularize it based on the epoch. So we can have some sort of a predefined callback in which after each 10%, you can have that print function being called to update that particular line.
Right. Okay. Okay.
Yeah.
I see what you're saying. Okay. So like a refresh buffer rate or something like that, where you just do it at that stage rather than doing it for every epoch.
Yep. Yes.
Okay. Yeah.
Interesting. I never thought about that. That's cool.
I think somewhere in this example, doesn't he show something like basically if epoch modulo 50 is equal to 0, so then you just print every 50th time, right? And so printing every time.
That's right. Yep.
I didn't see that.
I
Thanks.
think it's there somewhere. It should come somewhere.
Okay.
Sorry, where?
I think it's in 276. No. Maybe not in this, but yeah, that's basically you just do like if epoch modulo 100. So if you want to print every 100 iterations, so then you're not printing throughout. That could be a possibility, but yeah.
Yeah, I think this is the step, right? I think he's just printing every epoch rather than every step. In this case, yeah.
Hang on, let me check.
Anyway, okay. Anyone else has any comments, questions on this progress bar?
I've also seen the TQDM method being used quite often
Yeah.
too.
TQTM, let's look it up. TQTM Python.
DM.
DM, okay.
DS in dog. Yeah.
Cool. That's this one. Okay. Interesting. Yeah, I've seen this as well. I believe this is what FastAI does. I've seen, but I'm not 100% sure.
Yeah, FastAI has progress bar.
Yeah.
TWIML is being used by multiple libraries, including FastAI too. Yeah.
I think FastAI uses something called fast progress.
Fast progress. Okay. Fast progress.
Key point, if you end up using this in notebooks like Colab, just make a slight change on the import where instead of doing from TQDM import TQDM, you rather do from TQDM.notebook import TQDM. Because they have some problems with the general TQDM. The printing fashion you saw when you removed the carriage return, how it printed like line by line by line by line. There's a problem like that. So
yeah. Cool. Okay. Then we get to this now we're getting to the custom training loop. This is usually the last step when it comes to a training process, where you kind of call every class, every your customized loss function, and doing the updates together in calculating and getting your metrics, calculating your metrics, printing the progress bar, and specifying the epochs, having all the kind of hyperparameters set up here. So let's go through them. So 5 epochs, batch size 32, number of steps, then that's just length of X train divided, I think, divided by batch size. And this is division, but it gives you the full number, the integer. In optimizer, Keras, I believe Jeremy said something about this when he went through Fast AI. There's a better way to calculate this.
Right. And that's what
Yeah.
my question was, because that's integer division. So you basically, the last epoch, if it doesn't have 32 elements to form the batch, then
Yeah.
you have a remainder left there.
Mm-hmm.
I don't think that is being used in the current calculation, at least in the code. I couldn't make out whether it was being used.
Right. Right.
So,
yeah. There's a better, I think Jeremy came up with a better way to do this so that you don't have something that's left. And because, you know, if you think about it, if the last batch is, you know, somewhat smaller than, I mean, it doesn't affect the entire, you know, model as much, but just that last step, update step, you know, is altered somehow because of a smaller batch. And so he, you know, he wanted to take care of that, so he kind of altered this line of code to be something else. He used a different way of calculation.
So I think in the present case, we're not even using that last part. That's what I've been trying to figure out, but if I'm not wrong.
Yeah, you're right, Rekil. They just dropped that last.
Yeah, just dropped, yeah.
Batch size, which is less than the actual batch size.
We're not using the last. Where does it say that?
I think. Go ahead.
No, I was just saying that because if you do calculate n steps, right?
Oh, yeah.
And you're seeing the calculation, the second for loop, that is the third line in 276. You're doing only for 276, the one below. Okay. Yeah, actually, yeah. Why not just do that calculation? Then we'll see exactly.
362.
Rather just do a modulo instead of a division.
Oh, yeah.
Sorry. Yeah, so there is something left. So that's what's.
Yeah. So that the last, it's using 362 instead of, you know, 363, which would include 81%, you know, of the usual batch size, I guess. Yeah. Okay. That makes sense. Cool. So we're using NATM and learning rate of 0.01. Chars.losses dot mean square error as your loss function. Main loss, chars.metrics.main metrics, chars.metrics.main absolute error. So basically, for every single epoch, okay, we're printing the epoch, the number of epoch by the total number of epochs. Then for every epoch, then for every step of each epoch, we get our batch, you know, using the random batch. And then we have this context block of recording the gradients for the variables involved and get the Y prediction, your model X batch, get your main loss using the tf.reduce main and calling the loss function with your Y batch and Y predict, and adding your loss to the loss variable. Okay. And then get your gradients based on the loss here. Okay. And your model.trainable variables. Okay. And then you call the optimizers right here, which is your keras.optimizer NATM. Apply the gradients. And you use a zip here, zipping the gradients and the model.trainable variables together. Okay, and for variable in model.variables, if variable dot constraints not none, then you assign that. Get your mean loss for metrics in metrics. I think in this case we only have one metric in that list, but obviously you can keep adding different metrics, you know, to that list. Then print the status bar. Print the status bar, I guess, right here, and I think he printed twice for the step and for the epoch. Okay. Anyone has any questions or comments?
I have a comment. So it strikes me that this way of choosing a batch isn't optimal because you're going to get you're going to get a lot of duplicates, and it'll take you a lot longer to go through all the examples. Because every time you choose, you're not making sure that you're choosing new examples. And there must be a way to keep track of the batches so that every new batch is chosen only from examples that weren't chosen in the batches up until then. I'm sure there's a way to write. I'm sure there's a way to write a function that'll do that. I'm just not sure if if it is too time consuming as far as compute time goes to keep track of that. So maybe this is maybe he's deliberately losing out on this because it's faster. You know, losing out on being able to get unique batches because it's faster to do it this way. I'm not sure.
Yeah.
Actually, Joseph, if you just take, let's say, 1,000 examples and then just randomly shuffle that and then store that list, and then you just pick every batch size from that consecutively, that'll be much faster than this, and you won't get repeats then.
Yeah.
Yeah, there's the whole slew of techniques that the fast AI goes through in one of the library notebooks that shows that we've gone to in the fast AI library discussion of how to choose various random slices and various way to randomize too.
Cool.
Well, I think the way that that Rekil just said is a good way. I mean, I don't, you know, I'm not sure there's a better way than that. Just, you know, randomizing everything and then just choosing your batches from that. And so then you get a set of indices, right, that are all randomized. And then you just choose slices of those indices, one for each batch, non-overlapping.
Mm-hmm. Yeah, randomizing the indices, then just loop through that.
Yeah.
That makes sense. Yeah. Cool. I did not install this. Anyone tried this? Maybe I'll try it next time. Yeah. But I have not installed this. This IPy widgets is quite interesting. I've seen that being used in FastAI as well. You can sort of use that as a way to kind of tune your learning rates. You can literally control your learning rates like with a bar and while your model is training, and that's pretty cool.
Yeah, I thought it had problems with Colab though. It works when you run notebooks outside of, not Colab notebooks, but Colab notebooks have problems with that.
Got it. Good to know.
I think they came out recently with a fix though. I haven't tried it though.
Yeah, I haven't tried it with the fix either, but without that, and people were still complaining with the fix.
Cool. And I don't know why Colab actually has a lot of, it's not very user friendly for some reasons, and it's Is it because I'm not paying the money, not getting the Colab Pro, maybe?
No, I don't think the basic varies with the Pro
So
versus
too.
not. Yeah, so it's Colab is Colab regardless of.
Right.
Money just gets you better compute.
Right. Yeah, the user interface is not the best.
Yeah. But I think when you pay the money, there's Colab Pro. You don't have to wait, too long, when to get into the queue of GPU resources and stuff like
Doesn't
that.
log you out as quickly as
Right.
non-paid versions does.
Mm-hmm. Yeah. Cool. So I think this is probably a good point to stop, and we will, finish this up with the TensorFlow functions and graphs, in the end, and it's about like 5-6 pages, I believe. Yep, 5-6 pages. Then we'll finish, the next session with this. Yeah. Anyone else wants to say anything before we wrap it up? We're ending 10 minutes earlier today.
I had a question with the custom loss stuff. There's a mention somewhere where he talks about you can use the same. I think he uses Huber loss as a loss as well as a metric. And that's not today's discussion, mentioning I think last times or the time before that. So I think it's in the section, the custom loss.
Okay, custom loss.
Oh, hang on. That's what it's called, or custom metrics.
Custom metrics.
So there's a mention where he talks about how you can make your custom loss equal to your custom metric if you're using the same thing. Hang on, let me just find that on my side.
Custom metrics.
I remember that, and unfortunately, he didn't give any real physical-based examples of when you'd want to do that. He just said, let's just do this. We'll just for the sake of argument, we'll use the Huber loss for our loss function and our metric function, but he didn't really say why you would do that or what advantage it would give you.
Mm-hmm.
Right. I wasn't able to get matching results for some reason on the Colab notebook, though mathematically it sounded right. I was wondering if there was something that was missing there.
I think he was saying it was just precision error.
Yeah, but mine was like at the third decimal itself, it was off. So I don't
okay.
think. Oh, crap. Let me just see if I can. Custom loss functions.
I think it's probably here.
Let me check on the notebook.
Yep.
Sorry, it's under custom metrics. So if you open up custom metrics in the notebook, I can show you where.
Custom metrics.
Right, that section.
Yep.
Right before streaming metrics, he does that calculation where.
Right here.
Right there. See, I see. Okay, you're also getting 104 and 105.
Right.
Interesting, yeah. His example had the match exactly, so I was wondering if something was weird, but yeah, looks like the same thing.
Yeah, same thing. And I think he was just saying it was precision error.
No, I guess this should match. This I don't think is a precision error. This something else is missed. Although I don't know what. I don't know if it's that last epoch actually. No, No, actually, I don't know what it is. I don't think this was the one which he said was precision, right?
Moreover, when using the sample weights, there's more than just precision error, and he explained it here.
Right.
Yeah, so maybe that's it.
Cool. Okay.
Okay. Anyone else has any thoughts or comments before we wrap this up?
Yep. I would just like to correct myself earlier. I was a bit
Okay.
confused between FastAI and PyTorch and Lightning. So yeah, there they have used TQDM.
TQDM,
Yeah,
right.
yeah,
Hmm.
yeah.
Got it. Okay. Cool. Anyone else? All right. That's it.